By the end of this video, you will know all there is to know about the different types of joins in R. Let me show you the various packages out there that allow you to do joins, and let's test which one is fastest. Let's get into it. There are 4 types of joins that are commonly used. We've got the inner join, the left join, the right join, and the outer join. So let's go and have a look at a very simple example where we have 2 tables, table X and table Y, and we have some identifier. So in table X we have A, B, and C, and in table Y we have A, B, and E, and we want to join these tables. So let's have a look at what happens when you apply those 4 different versions of joins. The inner join will combine records from 2 tables where there are matching values in the common field. So in this particular case, we have A and B in both of the tables, and therefore the result of the inner join would be a table with only 2 rows, A and B. If we do a left join, we basically say give us everything from the left table and match with whatever we can find in the right table. So as a result, we get a table of 3 when using a left join. So we get records A, B, and C. But record C for value 2 will be blank because it did not exist in table 2, in the second table, or table Y. When we do a right join, we do basically the opposite. So we say, give us everything from the second table, from table Y, and fill in the data from X where it matches. So as a result, you get again 3 rows. In this particular case, we get A, B, and E, where the value 1 of E is blank because E was missing in table X. When we do an outer join, we say give us everything. So in this particular case, we get the result is a table of 4. We get A, B, C, and E with 1 blank value for C in value 2 and a blank value for E in value 1. And these are all the 4 methods combined in case you want to pause and have a closer look. So let's have a look how we can code this in the R language. For the purpose of today's video, I grabbed a standard dataset within R, the empty cars dataset, and I made it into 2 separate datasets. Each of the datasets has a selection of the columns, and then I removed at random a few rows in each of those datasets just to make sure that we can see what happens when not all of your rows match when you join tables. Both of the datasets will have the column model. We will use the column model to join the 2 datasets together. So let's have a look what that looks like. The original data set had 32 rows and 12 columns. Then the first data set we created is 28 rows and 8 columns. And the second data set, dfy, has 22 rows and 5 columns. We're going to use 4 different packages to do these joins. We're going to use merge from the base R package. We're going to use dplyr with their functions of joins. We're going to look at data.table and at SQL. Let's start with merge. So we have dataset X, we merge with dataset Y, and we want to specify a by. So model is the thing that is in common for both datasets. Those are the identifiers, and we can run this. As a result, we get 18 records because there are 18 records that are 18 models in common between the 2 datasets. Just a quick thing about writing our functions. You don't have to specify by in this particular case because you can see here that the default of by is the intersect of the names. So you can have a look at what the names of dfx are and what the names of dfy are, and the intersect is what matches. So model is the only thing that is common in both data sets. So if you would just run merge dfx, dfy, it will actually generate the same data set. But I think this is bad practice. So I think you have to specify as many parameters as you can just to be transparent. So always explicitly say what is your variable that you want to join by. And you can even say all equals false here for a inner join. At least it's very transparent what you're doing. So if we want to do a left join, there's one parameter that changes. The function is the same, but the parameter is different. So in this particular case, we say all of X is true. So we want everything of X and only matching records of y. So we can do this. So we get the same record as the same number of record as the original data set, dfx. Right join is we just change to all.y equals true. So now we say give us all records of dfy and the matching records of dfx. So the length of this data set will be the number of rows equal to the number of rows in dfy. It's 22 in this particular case. And the last type of join is the full join or the outer join, where we say give all equals true, and therefore we get back 32 rows, which is the same as the original data set. We should have a look though in the left join, for example, see if there's missing data. And if we look here, indeed, there is missing data. So in the Y data frame, there were a few models were not available, and therefore it puts blank data in all of the rows that were not available. Very often the column names are not the same in each of the data sets. So what do we do in that case? So I created a second data set where instead of model, it's now called car type. So if we wanted to run the example that we ran before, it'll give an error because model is not available in dfy_2. So what we need to do here, we need to specify that model is the by column in for dataset X, and then Y has their own join column. And when we run this, we will get back our previous result. So what if we need to join on two columns, for example? I have two data sets here, some age group and a sex, and then a number of events, and I want to add population from a second table onto the first one. Now I specify multiple by .x and multiple by .y variables. From dataset X, I want to merge on age group and sex, and the corresponding columns in dataset Y are age and sex. And when I run this, it joins the two datasets. Let's have a look at the package dplyr then. In dplyr, each of the different types of joins are different functions. So we don't go over it in too much detail because you can download this script and just run it by yourself and see what happens. So we're joining X with Y by model, and as a result, we get back our 18 records. We can do a left join where the function changes from inner join to left join. We get back our 28 records. When we do our right join, we get back our 22 records. And when we do the full join or outer join, but in this particular case, it's called full join in this package, we get back our 32 rows. So what if the names are different? We just specify by slightly different. We say C, open bracket, model, in quotes, equals car type. And that will return the data set. What if we want to extend that and join on multiple columns? So in that particular case, we just, after that, after the first column that we want to join, we do a comma and specify the second column. The third option is using data.table. So let's first create a, make our data frames into data tables. So when you look at the class, you now see that it's a data frame, but it also has a class called data.table. And then you can use the data.table merge function called merge.data.table. And you'll see that the specification is the same as the specification of the base R merge function. So we just have an X, a Y. We have to specify what we want to join it by. And in this particular case, we do all is false for an inner join. So interestingly, when you run the merge function, you will see that it actually works as well, because as soon as you feed merge with a data table, it actually grabs the merge data table and spits out the result as such. So we can do a right join where all.y equals true, and if we say all is true, we again do an outer join. That brings us to option 4, using SQL. I never do this, so I had to install my package, and then I can run inner join using saying select star, which select all from dfx, inner join on dfy using model. And I'm Like I saw this using model. It's not something I saw before, because normally what I specify is select X or select star from dfx, call that A, join on dfy, call that table B, and then the join is on a.model equals b.model. Return is the same. Then we can do a left join by specifying a left space join or a right join or a full join. So let's have a look which of these four methods is actually fastest. To do this speed test, I created two data sets of 100,000 rows long and I merged them 500 times. Here is a box plot of the results of each of the 500 iterations, and in the top I put the median time in milliseconds. So we see that the merge from the base package runs about 200 milliseconds. So merging two datasets of 100,000 rows long, you can do that 5 times within a second. You see that SQL is not much faster. And the methods that really stand out are join and merge data table. Relative to the base merge function, join and data table are both about 24 times faster. So if you're looking for speed, use join or merge data table. There you have it, all you need to know about joining tables in R.